All right, this lesson is on inverses of relations and functions. So what is an inverse? An inverse is a set of ordered pairs by obtaining them and switching the coordinates of each pair. In other words, the x coordinate becomes the y and the y coordinate becomes the x. So here's an example. Find the inverse of this relation. So we have a set of ordered pairs. So we have the x and then the y. And first thing we're going to do is just, is this relation a function? So if you remember back to earlier in our trimester 1, so for something to be a function, we do not want to have any repeated x values. So do we have any repeated x values? No. So here's all of our x values right here. They are our domain. So this is a function. And the reason why is there's no repeat x values. Then when we list out the domain values, -1, 0, 1, 2, and 3. Then we have our range, our y values. We list those out. -1, -2, -1, -3, and 1. Then what we're going to do is we're going to go ahead and find its inverse. So we switch the x and the y values. So now all the numbers in the green up above are our now x values. And then the x's become the y's. Now it asks us, is the domain and the range, what's the domain and the range? So we list out the domain are all the x values now in the green. And the range are all the ones in the red. Then what we can do is we can graph the ordered pairs. So I'm going to graph first the original relation. So I'm going to do that in purple. So I'm going to go left 1, down 1. So that was the first ordered pair. And then over 0, down 2. And then over 1, down 1. And then over 2, down 3. And when I'm doing that, I'm going to start to connect the points. And then over 3, up 1. So that is our original set of ordered pairs right here. Now next, in the pink, I'm going to graph these ordered pairs, the inverse of the purple. So left 1, down 1. Then left 2, up 0. I'm going to connect those points again. And then left 1, up 1. And then left 3, up 2. And then right 1, up 3. So that is the inverse. Now there is a reflection line that I'm going to graph in next at y equals x. So that's saying that the slope is 1 over 1 and the y-intercept is 0. So here's our y-intercept. And then we're going to go up 1, right 1, 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 and continue that, or down 1, left 1. Graphing every function and its inverse is going to be a reflection about this brown line here. So we notice if we were to fold on my smartboard or on this tablet, on this brown line, the pink and the purple would lie right on top of each other. That happens every time for inverses. When the relation is also a function, you can write the inverse as f of x as f to the negative 1 of x. So when the relation is also a function. Functions that undo each other are called inverse functions. So we can take a relation or a function and do this 4-step process to find the equation of the inverse. So step 1 is we replace the function with y. Step 2 is we interchange the x and the y in the equation. Step 3, we solve for y. And then step 4, we replace y with f inverse of x. And this is when we have a function and we want to find the inverse. So here's an example of doing that. So we want to find the inverse of this function f of x equals 2x plus 4. So what I'm going to just do first is I'm just going to graph this line. So here is our original function, and we want to graph it. So our y-intercept is 4, and then our slope is 2. So we're going to go up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1. So it looks something like that. Then what we want to do is we want to find the inverse of it. So I'm just going to create a little table here just so I keep track of my ordered pairs for my pink line, my original function. So I went over 0, up 4. That was my first ordered pair. Then I went right 1, up 6. Then I went right 2, up 8. So I'm just doing a few ordered pairs. So here's the ordered pairs that I'm denoting right here. And then I went down. So I went negative 1 up 2, and then negative 2 up 0. So that's these order pairs here. Now what we want to do is we want to go through the 4-step process to find the equation for the inverse. So if we look at this pink line, does it pass the vertical line test? Is it a function? Yes. So then we do the 4 steps. So step 1, I'm just going to write that first. Step 1 is to remove the f of x notation and just change that to the letter y. So this is changing it to a relation. So that's our step 1. Step 2 is to replace the x and the y with each other. So you're interchanging them. So the x becomes the y and the y becomes the x. Step 3 will always be the longest step. And what we do is we want to solve the equation for y. So we want to isolate the y. So I'm going to start off by subtracting 4 from both sides. So I'm left with 2y on the left. And then I'm going to divide both sides by 2. So I get x divided by 2, and I'm splitting that up, and then 4 divided by 2. I'm going to simplify. I get 1/2 x minus 2 equals y. And then I'm going to put in the correct order, so y is on the left. Now I'm going to go ahead and graph that line. So now my y-intercept is negative 2. And then my slope is 1/2. So I'm going to go up 1, right 2, up 1, right 2, up 1, right 2, or down 1, left 2. And I'm going to create my ordered pairs here. And I'm going to go back and finish that last step. So my 1 ordered pair, is over 0, down 2, over 2, down 1. I'm just doing a couple. That last step, so again, we're doing these pink steps right here. We replace f of x with y. We interchanged x and y. Step 3, we solve for y. That last step, before I graphed it here, the last step we have to do is step 4. We have to replace that y with f inverse of x. Now notice that our ordered pairs interchange. So here's 0, -2, and now that's this ordered pair here interchanged. And then -1, 2, when I graphed it out, that is the reflection point of 2, -1. So then could I find the rest of the ordered pairs? So I could take 2, 8 and interchange it as 8, 2. And then 1, 6, I would interchange that to 6, 1. And the last one, 4, 0. Now I did not create the reflection line yet. So remember that reflection line is at y equals x. So it has a y-intercept of 0 and a slope of 1.